If I do this with my left hand, my right cortex is starting it. It will change the tone of the muscle on my left side in general, which then the muscle tone on the left side changes muscle spindle cell settings. Cerebellum on this side is aware of that, changes activity, increases its activity, sends message to the cortex on my left side. That changes the tone in the muscle tone activity in the cortex on my left side, which goes down and increases spinal pathways ipsilaterally, creating muscle tone increase on the left side, which drives the cerebellum on this side, which drives the cortex on this side, and it keeps going round and round and round. And in health, if all the pathways are active, if all the neurons are firing like they should, if all the pathways are intact and have normal afferentation, and if the metabolic pathways of the cells are all good, so they're all firing like they should, you have normal, good health with one side of the brain driving the other, driving the muscle tone on one side, which drives the brain on the other side, which drives the muscle tone on that side, which drives the brain on the other side. And this normal figure of 8 pattern keeps us wound up and keeps us neurologically healthy as long as we have balance throughout our lives. But let's say the person doesn't move my left hand. Let's say the person breaks their left arm and now it's in a cast and it's not moving. All right? Person's got they can't move their left arm. What happens then? They can't move their left arm, so there's a decrease of drive to the cerebellum on the left, which decreases the drive to the cortex on the right. Now, the cortex on the right doesn't send so many messages down because it's not firing so much to the right side, so there's decreased muscle tone on the right in general. That decreased muscle tone on the right then doesn't stimulate the right cerebellum like it was before, which doesn't stimulate the left cortex like it does before. When the left cortex isn't stimulated as much as it was before, then there's decreased muscle tone in general on the left side. That decrease in muscle tone on the left side summates with the fact that you're not moving your left arm, doesn't drive the left cerebellum, so you don't drive the right cortex, so you get a decrease in activity in the left cerebellum and the right cortex, which means there's a decreased tone in the right cortex down to the right side of the body, which decreases the feedback into the cerebellum, which decreases the stimulus of the left brain, which decreases the tone on the left side, and you get a winding down of muscle tone activity and a winding down of brain activity. So when there's a problem or pathology or an injury or muscle imbalance or subluxation for a long period of time, you get a wind down effect. And so what you want to do is you got to intervene with that wherever you find the need to intervene it, because it could be anywhere along these pathways. You need to intervene with that process. And when you intervene with that process and start to restore cortical activity, then what happens when you restore cortical activity, if it's imbalanced on one side, you do affect both sides. You affect what's going on for meaningful activity on the opposite side of the body. You also increase tone on that side of the same side of the body, which increases the cerebellum activity at the same time, which drives the cortex to higher function on the other side, which increases the tone on the other side, and you get a wind-up. When you start to treat people with an imbalance in their cortical hemispheres, you start to treat the whole body, even though you're seemingly treating just one side. And things start to happen to patients which are very gratifying. You'll see patterns of activity start to take place in patients, sometimes in the office, sometimes following treatment as they get to use their parts more, but they wind up the whole central nervous system. They wind the whole thing up. And then they get better and better and better. And people heal, and they say, you know, I'm feeling better and better and better after treatment. I felt good after treatment, but I keep feeling better and better and better. That happens sometimes. We say, well, you're healing. Well, one of the things that's happening is they are healing, but part of that process is their brain is winding up as we got the problems out of the way that we're keeping it from operating in this normal wind-up pattern. And then when a person gets a problem, haven't you seen a person got an injury? It got worse and worse and worse to the point where they couldn't function anymore? Haven't you seen this sometimes? Have you ever seen a patient got hit on the head? Concussion sometimes, and they're or had a car accident, they got banged around a lot. They kind of start to recover, start to heal a little bit, and maybe they heal from the acute injury. Maybe they had a bump on their head and now they don't have a bump in their head anymore, but they keep getting worse and worse and worse. And after a while, they can't tie their shoe. And after a while, they can't talk without stumbling over all their words. And after a while, they can't read or write without getting a headache. And they lose their balance. I mean, this is wind down that comes from an injury which affects these pathways. And so we have to help to figure out where to intervene so we can start the wind up process again. Now, this is huge.